Okay, I'm going to cover some basic exponent rule things using problems 1, 2, 3, 4, and 5 from test review number 4. So when we have a situation where we're multiplying exponents of the same base, you simply add the exponents. And then looking at it conversely, when you're dividing, that's when you subtract exponents of the same base. Alright, so for this situation here, it simply becomes, let's try that again, it becomes x4 plus 6. So you still keep the base and you add the exponents, which gives you a new exponent of x to the 10th. And then how that works, really, if you look at it entirely, it's like drawing 4 x's, because that's x to the 4th, x times x times x times x. And you multiply that by the 6 x's, x, 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 and that really means it's x to the 10th power. It's a terrible 10. Because you have 10 x's. Okay, but we simplify it and just add those exponents. In this situation, be very careful because you have this negative in front. That always makes it a little trickier. And the best way to look at this problem is you separate these pieces. Take that negative, make it a -1. And we could put it in parentheses. And then you have -8. And go ahead and put that in its own set of parentheses. And x to the 6th. And then -2. I like to keep negative integers in parentheses so it keeps it clear. And then you have x squared. So in this situation, you're going to combine like terms, which means you can multiply the numbers and you can multiply the exponents with the same base. So we're going to multiply the -1 times the -8, which gives us a +8. And then we can multiply that +8 times the -2, which gives us a -16. So times -2. So we have a -16. Then we're going to take these exponents. They have the same base of x, so we can add them, and that gives us x to the 8th power. So our total answer becomes -16 x to the 8th power. That's a term, a simplified term. And for this problem here, problem 3, we have to do the same thing. We've got a lot of letters and we've got some numbers. So let's separate the numbers. We got 8. We have that -4. And we have an x to the 5th. And we have an x to the 12th. And we have a y to the 3rd. So we combine our like terms, which is multiply the numbers. That gives us -32. Then we can add the exponents of the same base, and that gives us x 17. And then we don't have anything to do for the y except for leave it alone, y to the 3rd. So that's the answer to number 3. In this situation, you could look at it one of two ways. Any number over itself is 1. Doesn't matter what in the world it is. It's x over x, x to the 100 over x to the 100 is always 1. The other way to look at this problem is follow the exponent rules. You do x, subtract the exponents, 5 minus 5 equals 0. So you have x to the 0 power, which is not 0. Anything to the 0 power equals 1. So you still have the same answer no matter which way you look at it. Okay, and on this one, the trick is let's see, what color should we use? Let's try purple. Is to look at the 6 over the 2 as combining like terms, those combining the numbers, and you look at these that you can combine, but according to exponent rules with division. Okay, for exponents, you subtract the exponents with division. For numbers, you simply divide. So 6 divided by 2 becomes 3, and then x is 6 minus 3, so the answer is 3x to the third, and it is done for that.